Welcome to this JupyterCon talk entitled IBM Quantum Experience Notebooks, serving JupyterHub at scale for a quantum computing community. My name is Juan Cruz Benito, and I work as a senior software engineer at IBM Quantum. The purpose of this talk is to share with the community our experience while integrating JupyterHub into an existing platform like the IBM Quantum Experience. To do that, we are going to discuss the challenge and the solution we propose, our experience while deploying and integrating JupyterHub into the IQX, what issues we found and what of them we solve, and the relevant learning we acquired during the process. At the end, we want to share some future challenges we want to pursue. Okay, first of all, what is IBM Quantum Experience? IQX is the platform that provides online access to the IBM Quantum computers. It was released in 2016, and currently it provides 11 available public devices. It includes different tools for free to foster the learning of quantum computing and the use of the quantum devices, like the Visual Circuit Composer, Jupyter Notebooks on the cloud, tutorials, exercises, etc. It has about 240,000 users. Okay, what was the challenge? The challenge can be divided in different bullets. First, provide a Jupyter-based environment to allow the users to code our quantum computers using our libraries, like Qiskit, directly on the cloud, with no local installations, no dependencies, and no previous knowledge from the users. Second, provide controlled hardware resources and storage for each user. Enable potential customization of resources available depending on the type of the user, like regular, premium users, etc. Third, customize the Jupyter environment to be consistent with the UI and the UX of the IBM Quantum Experience. And fourth, enable all of them for all of our users. What was the solution proposed? Deploy a JupyterHub into IBM Cloud via Kubernetes using Zero to JupyterHub project and its documentation. Create a custom authenticator to log in the users using the existing infrastructure we have. Also, update the Jupyter default UI, develop and integrate a custom Jupyter extensions to help our users, and embed the Jupyter environment into IQX via an iframe for now. What issues we found and what of them we solved? First of all, no one deployed before us JupyterHub on IBM Cloud Kubernetes, or at least no one contributed the process to the official documentations. Also, configuring the system for advanced features and use cases can be hard. An interesting point is that free resources are free for crypto miners. In our case, we ran an automated system into our deployment to remove that malicious users that use our resources to mine cryptocurrencies. Also, embed Jupyter Notebooks served via JupyterHub into another platform is not easy. Even more when you try to use secure protocol like CSP, CORS, etc. In this case, we did not invent anything, yet we would like to contribute part of our improvements on our learning to this side. Also, part of the JupyterHub core processes and modules are not designed or configured to manage a huge load of concurrent users. This raises a lot of issues for us. Related to this kind of issues, we contributed things like pagination for admin dashboards. To improve the usability of big JupyterHub deployments, you don't need to wait for every server, every user you have in your system to display on the same dashboard. You can paginate as in many other systems. Also, we reported and helped to scale up some configuration and modules for thousands of users. For example, when checking the status of the servers while they have a startup, it's not the same to check 100 servers than 50,000 servers, for example. Knowing the actual limits of a real JupyterHub deployment is not easy. We are contributing methods to stress test big deployments and check how many concurrent servers can be managed. Check this link to see our current work and what things are we contributing to the community. Also, resilience and reliability in big deployments is very complex. We contributed code and recommendations to manage at least 3,000 pods with no issues. Check the last version of the QSpanner for more information. Okay, relevant learning. First of all, and this is a thing we would like to highlight, the JupyterHub, Jupyter Zero to JupyterHub and Cube Spawner community is awesome. Kudos, thanks to everyone involved. Second, it's not easy to run big JupyterHub deployments even when using Kubernetes and Zero to JupyterHub. There is a lot of knowledge needed to succeed in this area, from users' knowledge about the Jupyter ecosystem to choose the right things to use, to Kubernetes internals, how to monitor and scale up your deployments, etc. When you are dealing with a large number of users, or you are in the middle of a worldwide event with thousands of people trying to use your JupyterHub instance, plan carefully the resources needed and the number of Kubernetes pods and user servers you can create and spawn currently and concurrently. Also, take this in mind, JupyterHub placeholders are your friends. Try to stress test your deployment as much as possible. We are contributing some solutions to make it easier, but there is a lot of things that can be done. Considering the learning acquired during running some big events in our deployment, and especially after stress testing it, we are ready to go from 800 concurrent users to several thousand. We have tests with 3,000 or 5,000 users concurrently at least. The right customization of the JupyterHub base image and the user base image can help you to improve a lot the user experience. In our case, we take advantage of that thing to deliver learning materials or tailored extensions and resources for our users. The Jupyter UI lacks of a good system to allow them embed into another platforms. Probably it will be good to work on this. Also, the Jupyter ecosystem still lacks of proper tools to enable users collaboration on the same notebooks or to let them share files. Projects like the Jupyter Real-Time Collaboration or the Jupyter Lab Google Drive are more than welcome right now. Usually, a custom authenticator is not needed, so don't reinvent the wheel. If you need your own one, extend one of the 16 examples. Also, if you code it carefully, you can unblock new features when you log in your users. Also, a custom authenticator is not easy to test. Put effort on testing it adequately and automatically if possible. Okay, what are the future challenges we want to pursue? First of all, extend our work on making big JupyterHub deployments reliable and fast. For example, work on the ability of running different hub replicas to reduce the downtime on hub upgrades. Also, we would like to improve our deployments to be able to manage higher amounts of concurrent users. We would like to improve the tools for admins and to manage the user roles and resources. This is going to be much needed in case of big deployments like our own one. We would like to improve Jupyter UI and embedding capabilities. And also, we would like to contribute to Jupyter projects on collaboration and file sharing. Finally, I would like to thank many people. This work would have been impossible without the help of many members of the IBM Quantum Club team. Thanks to all of them, especially to Sean, Renier, Matt, Ryan, Raul, Fran, Paco, and Isma. All the images used in this presentation belongs to IBM Quantum and Project Jupyter. Thanks for your attention, and I'm eager to answer your question if you have any at the next JupyterCon conference. Thank you very much.